I'm recording. Sorry, I didn't tell you that. We're going to start off with this page here. If you would love to get, you're going to need today, you will, a ruler. So let me actually pick them up because you'll need them. Your 4 is going to need them. Okay. So, I highly recommend coming and getting a ruler for today. We're going to be drawing lots of straight lines. So this notes that I have right now is preparation for our lesson. And you're like, what's our chapter about? Our chapter is going to be about having 2 lines and finding out where they intersect. It's called their solution. Or if I give you 2 equations in standard form, ax plus by equals c. If I give you 2 equations in standard form, what is the xy ordered pair that works for both equations? So it's going to be me spending time doing a standard form of one equation and then another equation. And my job is to figure out what is the xy ordered pair that would fit into both of those. And please know that a, b, and c are numbers. A 2, a 5, a -1, anything. So let's get started. You all need a ruler. I have way too many on my desk. Does anybody in front of me need a ruler? Thank you. Okay, here we go. The solution to a system of equations is the point where the lines intersect. Okay? So here we go. Y equals mx plus b. If you need a reminder, I will. My b is the y-intercept. My m is rise over run. I begin with my -5. So on my first example up here, I'm going to begin at -5. And then my slope is 1 over 1. Rise 1, run 1. I want you to go backwards and frontwards. Backwards means I go down 1 and left 1. And then back to my y-intercept of -5. Go up 1 over 1. I do not want you to make 30,000 points. 4 points is good. 5 points is good. Connect the dots, la 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 la. Make the line long because I don't know where the intersection is going to be. So I've already graphed my first equation, y equals x minus 5. My second equation is y equals -2x plus 1. My begin is at 1. My slope is -2 over 1. Down 2, right 1. So on the same graph, I could make it a different color. It doesn't matter, but begin at 1. Down 2 over 1. Down 2 over 1. Ooh, they intersect. I see their intersection point. Their intersection point is right here. That's the point that I say is the solution. It is the ordered pair 2, -3, 2, -3, and that point is where my 2 lines intersect. So I'm going to say the system has one solution because the lines intersect once. Okay. Next one. Graph them both. Y equals 2x plus 2. Y equals 2x minus 3. 2x plus 2. Begin at 2. My slope is 2 over 1. Rise 2, run 1. I'm going faster because I feel that you should also be able to, without any difficulty, graph a y equals mx plus b equation. Let me go do one more dot. Okay. Graph the second. Y equals 2x minus 3. We just talked about this last chapter, you guys. This is like a translation. Instead of my y-intercept being at 2, now my y-intercept's at negative 3. Rise 2, run 1. Oh, hey. What do you notice about what this line is doing? What's so interesting about this line and this pencil line? What do you think? Huh? They're parallel. They never touch. The solution is none. The system has no solution because the lines are parallel. A solution is only when the lines touch. Okay. Last one. The first equation looks good. What's wrong with the second equation? Yes. Here, yes, I have to put it in y equals mx plus b, which means I need to divide by 2 first. 2 divided by 2 is 1x. 6 divided by 2 is 3. 1x plus 3. Wait, what? The top one says 1x plus 3. Begin at 3. Rise 1, run 1. Down 1, left 1. Huh. And my second line is the same thing. So I really don't need to do this red line, but I will just, You guys, how many times does my red line and my pencil line hit? Like, how many times is this hitting? How many times do they touch? 3 or 4 times? Any more than 4? Yeah. Every time. They hit all points. Every single decimal in the middle of a box, in the corner of a box. Every single decimal. This is called infinite times. More than you can count because the line goes on forever. The system has infinite solutions because the lines are the same. Because the lines are the same. They are. Are we ready to turn the page? This backside is another example of, one solution, no solution, infinitely many. But as you can, but what I'm going to do is I'll graph them, but I'm just going to graph fast. So you guys work on your own right now. I'm going to graph them on the screen, but I want you to graph them on your paper. Y equals 4. Is that horizontal or vertical? Horizontal or vertical? Y equals 4. What does that look like again? Y equals. So go to the y-axis and do a dot at 4. Horizontal. Good. Y equals 2x minus 4. Okay. Begin at negative 4. That's my y-intercept. Rise 2, run 1. Up 2, right 1. I need to go until I hit this other line, you guys. There. I have to keep making my dots until my lines hit. Because otherwise, I won't know what the solution is. There's my solution. What order pair is that? Over what? Up what? Over how many? Up how many? 4, 4. Oh, sorry. Systems with one solution have equations with different slopes. Sorry. 4, 4 is my solution. No solution. I have to distribute first. If I have the same slope, then the lines are never going to touch. If the lines don't touch, they're never going to have a solution. If they're parallel lines, they never have a solution. No solution. Parallel lines. And infinitely many means it's the exact same line. So I have the same line basically just on top of each other. Systems with infinite solutions have equations with the same slopes and y-intercepts. They are the same line. One solution, no solution, infinitely many solutions. So now we're going to transition to your notes packet. And your notes packet is 4.1a. This is the easiest section because as you can see, we're just graphing lines and looking at where they intersect. Here's notes for 4.1a. Irrational. Real quick recap. Right? A rad 8 times a rad 2. Well, actually, you guys multiply it. It's rad 16. I can do that with multiplication. The property of multiplication and square root says that I can multiply it. Okay? So, this is going to be a rational number. It's asking us which is irrational. An irrational plus a rational is going to be irrational. Part C, irrational. Oh, did I skip A? Sorry. An irrational plus a rational is an irrational answer. An irrational times an irrational is still going to stay irrational. Because if I multiply a number that never ends by another number that never ends, two rad 3 plus 5 rad 3 is 7 rad 3 minus 7 rad 3. Ooh, these cancel out. 0, that's rational. They're only asking us which ones are irrational, so that would just be A and C. So I actually had to do some math first, you know. Solving for x. Let's make sure you did not forget. Keep the 7x there in front. Then distribute. Minus 21x plus 15 equals 5. I'm going to combine like terms. 7 take away 21. Negative 14x plus 15 equals 5. What do I do next? Someone tell me quick. Subtract 15. Negative 14x equals negative 10. Well, that's not that exciting. Maybe it is exciting because it's an improper fraction. Or it's not improper, it's normal. 10/14. 2 goes into both of them. Right? 5/7. So don't forget how to do these basic things. All right, example 1. What is the solution of the system of equations? All right, well, we are just graphing both equations on the same graph. Please notice this decimal point. What's the same as 0.5 or 50 cents? What fraction should I use for rise over run? Yeah, 0.5 is 1/2. Graph both intersections. Go. Part A and part B. We're going to do them both. Use a ruler. Make arrows at the end of your lines. You have to get in the habit of being good graphers now. All right. So you're probably way ahead of me. Did you make sure that with your negative 2x, it was a downhill line because it had a negative slope? Do you remember those key parts? If I'm trying to make my lines connect, I need to make my lines really long. Because if I don't make my lines long, I won't know where they hit. So what am I doing? Like 6 dots here? Ah. Rise 1, run 2. I need to go backwards on my 1/2 x plus 6. I really do. If I don't go backwards, they'll never intersect. So reversing your graphs. Okay. My point of intersection is negative what? Someone tell me out loud. Someone new. Yeah. Negative 4, comma 4. Checking that the solution works. Let me tell you how to do that. You plug it in, plug it in. If I think that my x is negative 4 and that my y is positive 4, I am plugging in those values for x and y. Let me show you what that looks like. For the top equation, y equals negative 2x minus 4. Instead of y, I'm going to put a 4 because that's what I think y is. And instead of x, I'm going to put a parentheses and I'm going to plug in what I think x is. I think x is negative 4. Does 4 equal 8 minus 4? Yes. This is one of those things that, we teach you, and this is a way for you to make sure that you're getting the problem correct. Now I'm going to plug it in for the decimal. I'll just put 1/2. I think y is 4. 1/2 of negative 4. Instead of the x, put a parentheses and a negative 4. Okay. So, does 4 equal negative 2 plus 6? Yes. So this is, honestly, it's optional. It's like with equations. You had teachers that once taught you to plug in your x answer to see if it worked. Yeah. It's okay with me if you don't check your answers. But if you want to verify, you want to make sure you want to get 100%, check your answers. Okay, graph part B, please. If you haven't already. We'll be going all the way to the bell today, guys. We have lots to do. Y equals 1/2 x minus 2 and 3x minus 7. So go ahead and do that on your own. Do you need guidance still on this? My m is 1/2. My begin is 2. Begin at negative 2. Rise 1, run 2. Begin at negative 2. Rise 1, run 2. I don't know how many dots I should make, but I do know I need to reverse it. And I need to make a really long line. Next one, begin at -7, rise 3, run 1. Ooh, that's where it hits. Find the point of intersection. Am I going too fast? No. Two, -1. Do you agree? I'm not going to check it. I mean, if I really wanted to, I would do it 1/2 times 2 minus 2. That's what you would do, but I'm not. Just due to time purposes, you know. You would plug it in, plug it in. Can we turn the page? Okay, let's just do one of these. Let's do B, the harder one. It's not in y equals mx plus b form. Let's practice changing from standard form to slope-intercept. X minus 2y equals 8. -4x plus y equals -4. So I put both of them up high because I knew I need to change them to y equals mx plus b. Slope-intercept form is when the y is alone. It's isolated. So I have to move the x term first. Minus x. And I put it up here, but now I'm out of space. Darn it. -2y equals, what goes right? -2y equals. What goes right after the equal sign? The slope, the x term. -x plus 8. I'm running out of space. Y equals, I better do it somewhere else. Y equals, what's -x over -2? -x divided by -2. How do I write that? This is such a good one. -x divided by -2. What's the slope of -x and -2? Yes. Hojan. 1/2. And I'm going to put the x after it. It doesn't need to stay on the denominator. It doesn't need to stay on the numerator. What's 8 divided by -2? Out loud, someone. 8 divided by -2. -4. Thank you. I'm going to change the other one. Add 4x. Y equals, and this is like ready to go, 4x minus 4. Those are my two equations. They are in slope-intercept form. They're ready to go. All right, go ahead and graph them. You don't need me. Oh, I might not even have made that long enough. Darn it. I did make it long enough. What's the solution of this system? 0, -4. It's the y-intercept. I'm not going to check. But if I did check, do you have some part of your homework tonight where it does say check? It's like this. Decide whether the ordered pair is a solution. So you just plug it in. Oh, we're not done with notes. I'm just like showing you this. I have to plug in x for 5 and y for 2 for both equations. 3 times 5 minus 2y, 2 times 2 equals 11. 3x minus 2y equals 11. And negative x plus 6y equals 7. So I'm plugging in my x and y to make sure, is it a solution? Yes or no? And I say yes or no. So did you guys copy down number 11 at least? Your homework tonight is 1 through 16. Lots of graphing. All right, I'm about to turn this paper off the screen. This is in the homework packet that I gave you. I gave you 2 white packets. Now, this is just a recap of homework. You are doing 1 through 16 for homework. And now I'm going back to the notes. Because I want to go. We're kind of doing all this in one day. But 4.1b is exactly what we did at the beginning of the period. One solution, no solution, many solutions. One solution, no solution, many solutions. So, can you guys go to notes? You know what I'll do? We'll do the word problem. Write and solve a systems of equation for each situation. This is in 4.1b. Roshan has saved $150 and continues to add $10 each week. How do I write the equation for Roshan? I'm going to say, I don't know. Roshan, let's have Roshan be a boy. He saves $150 and adds $10 a week. How do I write that? I have $150 and I add $10 every week. 10, 10, 10, 10, 10. What does the X go with? The 150 that I start with, or the 10, 10 each week that I don't know how many weeks? 10. Here we go. Do you want to do 10x plus 150 or 150 plus 10x? It doesn't matter. So this is equals y. I could put the y after or before. How about Keegan? Keegan starts with $0 and saves $25 a week. Oh. Keegan has to save more every week, but he started with nothing. What is it? He starts with nothing. This would be his initial value. Remember from last chapter? But this is his rate of change. 25, 25 each week, 25. What's my equation say? Y equals... Come on, somebody. 25x. And I'm not going to put a plus 0 because it's a waste of your time. You just need to know that there's no y-intercept. And it says solve the system by graphing. Use Desmos. Which means... Okay. Here's Desmos, you guys. 10x plus 150. So in Desmos, I entered 10x plus 150. And then, which by the way, I can't see the line because the y-intercept is so high up there, 25x. Whoa. I move out, I zoom in. Where is this point where they intersect? There. 10, 250. The x value is 10, the y value is 250. In how many weeks will they have the same? 10 weeks. In 10 weeks, they're going to have $150. They're going to have the same amount, which is going to be $250. Oh, wait, you can see that. Sorry. So, in 10 weeks, they will both have $250. In 10 weeks, they will both have $250. That's good money. But you have to have discipline to save it and not spend it, which is extremely important in life, to not just spend. You'll have a lifetime of pain if you just spend and give in to your greed. I want this. She has that. I want that. He has that new thing. I want that new thing. You will always be unhappy. So, our job today is we graphed and we found a solution. We figured out that if lines are parallel, they have no solution. If the lines are the same, that's called infinite solutions. And your homework is 1 through 16 on the front page I gave you. Okay? So, that is 4.1b. I will stop the video.